All right. Assalamualaikum. Hello and good afternoon, everyone. So thank you so much for attending week 7 of Skills Up SuperMap. So today you will be learning about our traffic analysis. Okay, so as usual, I am Anis as your moderator for today. And for your information, this workshop is being broadcast live on YouTube. So you can subscribe to our YouTube channel. And then from there, you will get various of updates from our platform, which is iDesktop, iServer, and also iPortal in the future. Okay, so before we start, I would like to invite all of you to our international workshop on GIS technology and application, which will be happening today until Friday. So you can just scan the QR code here, and I will send the link to the chat box later. Okay, so this workshop will be held from 30 November today, right after this training until 2 December. So our speaker come from all around the world: Germany, China, Malaysia, Indonesia, and also Bangladesh. Okay, so I think let's move on to our target today. So today's training will be presented by Ms. Nur Shafika as our technical engineer from SuperMap. All right, Shafika, it's all yours.
All right, thank you, Agnes. So, hi and hello, everyone. Glad to see you again in the 7th week, or we can say our second last workshop for Skills Up with SuperMap. For today's topic, we will learn about traffic network analysis by using SuperMap IDAS.S. Before we start, regarding the last week session, I would like to apologize for the data problem, and I would like to inform that the new file has been uploaded and you may check it on your drive. So as usual, if you happen to have any inquiries, you may type it in the chat box or just email us about the inquiries. Now, we need to take an overall view about what can SuperMap traffic analysis done. So, where in SuperMap, this traffic analysis could help users to solve their traffic problem, as well as we have several analyses that can help to solve it, such as optimal path analysis, transfer analysis, service area analysis, location and allocation, and so on. This is what SuperMap traffic analysis can do and helps users to solve their traffic problem. So for today, we will focus on the traffic network analysis, indoor navigation analysis, and lastly, before we go to our last session, which is live demonstration. First, we will take a look about traffic network analysis. As we know, network analysis facilitates the commerce and public services, as well as our daily life. The analysis results can help to provide an effective implementation proposal to help the user to make much more rationalization. Yes. Okay, but before we start and go deeper, we need to know what is network system, and also network model, as all of these are related with our analysis. Basically, network is a model that composed of a group of interconnected lines, nodes, and their properties to express roads or pipelines and others. In the world of geographic information, public infrastructure such as power facilities, cable TV networks, road transportation, water networks, and others, all of these are abstract as a network system, which it is being composed by many interconnected lines While for the network model, it is actually the abstraction of the network system of the real world. For example, we have urban transportation network, where the road and other linear features are abstracted as line segments, which are also called as the network arc. While the crossroad, the bus stops, and the other point-like feature are being abstracted as points in the network, which are also called as the network nodes, which we know on these points in this network system as nodes. Where in the network model, resource information can be transferred from a node to another node along the arc, where we can consider the network is being composed of the edges or lines that is being intersected or the intersect points or node and any other element, where it will represent a possible path from one location to another one, where this is example of the network model that we have, such as the water part and part 9. Sorry. Sorry. Okay, so as shown in the figure above, the network not only has the abstract topological relationship between arcs and nodes, it also has a geometric location feature and geographic attribute features of GIS spatial data, which it is including the topological relationship, cross correlation between a geographic objects in spatial location, where these following are being described as the basic concept that is involving in the network model, which are the nodes, arc, center point, turntables, impedancy, and so on. So nodes are actually the places that are being connected, where arc connects the networks, where it represents the railroad intersection and reverse intersection. R is while R is an edge in network that connected with another arc by nodes. It can represent the highway, railways, or transportation network. I'm sorry. Okay, so center points are being discrete devices which are located at the nodes of the networks and have the capabilities to accept or provide resources. So this is the nodes. This is the example of the nodes, and this is the center points. And obstacle, and this one is the obstacle point. Okay, lastly, we have a turntable where it is the process that arc passes through the middle node to arrive at the adjacent arc, where turntable will help to save the cost of the turning, and it can list or must list all the possible turns in every crossroads. So for the network analysis, it is actually a procedure performing on a network model to solve a practical problems, where this has been widely used on many fields such as digital navigation, traffic and travel, pipeline design, and so on. So the differences between this traffic network and public facility network is traffic network has no direction, since the resources can decide their direction, where they can decide their direction such as space and so on. While for the public facility networks, it has a direction where it will depends on the sources. So as you, for the example is like it has been explained here, which is the direction of commonly used network like natural gas pipelines and railway, where we already decide where it has a direction. While for these traffic networks, we know that we cannot specify the direction of pedestrian or transport resources, where it will be decided by the pedestrian itself, where they want to go, the direction, the speed, and the destination. So this is what we will do in the traffic network analysis, where we need to, where we have the optimal path analysis first, and then we will do a we will find a closest facility. We also have a travel salesman analysis, service area analysis, logistic distribution analysis in our traffic network analysis, and also resource allocation and location allocation analysis in our SuperMap desktop. So how to perform a traffic network analysis? So this is actually the procedure for traffic network analysis, where in the SuperMap, the basic step to execute any type of network analysis are as follows, which we will need. First, we will need to prepare the network or build a network dataset, where it can be built either in 2D or 3D network. After that, we will add the network dataset. And then we need to set the network analysis environment, where how to set this environment of network analysis. You need to set the parameters of the environment setting by change the style settings, traffic rule settings, table settings, and so on. After we done set the analysis environment, we will create a new instance of network analysis, such as optimal path analysis, service analysis, and others. After we done creating analysis instance, we will set the analysis parameter, where we perform the service area analysis that being needs to set whether the service radius and the analysis direction start at the service station, and so on. Lastly, after we done build the network dataset, set the environment, create analysis instance, and also set the parameters, we will perform the analysis and check the analysis results and the path guide. Okay, so for this one, we will build a network dataset, where network data is the basis of the whole network analysis, where all the features on the network analysis should be performed on the network layers. So how we can build the network dataset? Firstly, we need to construct a network dataset, where we will abstract the objects to be analyzed into points and lines. And then we will use the network data model to give the abstract points and line a certain topological relationship, thereby simulating the relationship between corresponding features in the real world. So in SuperMap iDesktop, it supports constructing a network topologically, which resulting in network dataset, where you can specify the point dataset, line dataset, or network dataset to generate a new network dataset. So this is what I told you previously, where you can set the analysis environment, where for the styles, we have like under network analysis environment setting, we have a style setting, traffic rule setting, turntable setting, and weighted value setting. So where for the style setting, you can specify the style before performing the analysis. Like you can specify the style of points, line, and polygon. And then you can also set the traffic rules settings, such as opposite traffic, forward traffic, and no entry, and so on. And you can also set the turntable setting and weighted value setting, depends on what analysis that you want to do. So this one is the when we want to create an analysis instance. So instance management manage the analysis instance, which is a process to solve the practical problem by analysis in the network model, such as path analysis, service area analysis, and closest facilities. So Currently, network analysis has been widely used in transportation, telecommunication, logistics, electric power, and so on. So this feature, which is find closest facility, which fell under analysis instance, will help you to find one or more nearest facilities toward the certain area based on the travel time or distance, where it will show you the optimal route, cost, and so on, from one area to another area. Where this feature can help you, especially during the emergency, when you want to find the closest area towards from your areas towards the another area. So for example, when you want to find the closest petrol station, when your car out of petrol, or you want to find a nearest hospital when there is an accident, and so on. So this feature will help you to find the closest facilities towards to the area that has an accident, or your area, like from where your car is. So next we have a location and allocation, where we in this location and allocation, it helps to select the optimal locations from many candidate positions according to the specified parameters. This location allocation analysis will helps to provide the reference for finding the location of the service facilities. So as you can see, it can help the position selection of chain supermarket and so on. Where this is the example when you want to select a 7 hospital to do the medical examination. So you need to find the nearest hospital that you can go either by foot or by bus. So after you do the location and allocation analysis, you can get the nearest 7 hospital that you can go within 30 minutes, either by bus or on foot. So this is the example. Yes, so next we have the path analysis, where the path analysis is one of the commonly used functions of the network analysis, where in real life, we need to find the shortest route between 2 points, which may be important for the transportation, fire protection, disaster relief, and so on. So during the transportation, we need to find the route or the least transportation cost during the disaster relief. So we need to find the route of the least time cost and has the lowest cost when you want to go there. So actually, the path analysis is used on the specific network to find the shortest path passing through many routing points in order to minimize the cost and the time that is being required. While for the trip traveling assessment analysis, it is including the shortest route analysis. Okay, so for this path analysis, we have two, which is optimal path analysis and a traveling salesman analysis, where this optimal path analysis have the shortest distance, least cost, and minimum spend time. And this traveling salesman analysis has you can specify the start point and end point. Where this traveling salesman analysis will not follow any order, while for the optimal path analysis, it will follow like the order from 1 to 7, like you can see here. It will go from 1 to station 2 to station 3 to station 4 to station 5 and 6. While for the traveling salesman analysis, although the station 2 is here, it will go to the nearest area, where you can see it will go from station 1 to station 3 first, and then station 4, station 2, and station 5, where it will not follow any order. So this this is the example of the analysis in Stair where we will find the closest facilities. So first, it will click the routes and do the 2D network analysis. Then after we build the 2D network, we will find the closest facilities here. So we will know which area or which facilities are the closest one from the accident area. So this one, they import the data. So you will run all of this and you can see which facilities are nearest the traffic accident location. So next we go to the navigation analysis. So nowadays, as we know that there are a lot of traffic development that's making we need the navigation analysis in order for user to know the route information and can helps to find the optimal path to the destination. So navigation analysis is basically being run based on the different algorithm of optimal path analysis, in which including the navigation and navigation analysis and also a route planning. So navigation analysis has a different algorithms and it is being constructed based on the network dataset where the model data stores the environment information which is being required by the navigation analysis. Therefore, you can perform the navigation analysis without the setting the environment parameters again. So for the route planning, this feature actually helps to compile the network data and navigate it based on the resulting data. For this, it uses less internal to load the data and have the high performance analysis. Where this feature is being applied to the navigation application on the mobile side, as we know on the Waze or maybe Google Map or in your area, I think Waze mostly. So this is the scenario of the application in a real life where we have the optimal path analysis, which is based on the network dataset navigation. Network dataset navigation analysis, which navigation analysis has the high performance and applicable to the web. While for lastly, we have a route planning, where it compiles the standardized route net data that include the path information, where this route planning has the high performance path analysis. Lastly, for our traffic network analysis, we will have indoor navigation. So nowadays, we have a more complex routes and complicated building structure where sometimes making the recognition of the position much difficult, especially in the large scale area such as in malls and airports. So a lot of people can't find their ways. So SuperMap iDesktop provides a comprehensive solution where it includes the production, loading, and analysis of the indoor navigation data. So we can, by using SuperMap iDesktop, we can navigate across the floors and build floors and buildings, build indoor dataset. We can do 2D and 3D integrated navigation, and also we can do indoor and outdoor integrated navigation. So first, before we do the indoor navigation, we need to build the navigation model where we need to have the indoor or outdoor routes data, stairs data, and turns data, and also POI data. After that, we have all of the data. After we build the navigation model, we later will build the stairs relationship according to the network data set of each floor and floor relationship before we do the navigation analysis, where we will load the navigation model data to perform the analysis. So after we finish all of this analysis, we can do the indoor navigation. So this is the data types that are needed to build the navigate models, which it is as shown in the slide, which are the indoor network data, stair point data set, entrance and floor data, and also outdoor network data, where all of this will have to build the indoor navigation model. As we know, to build stairs relationship must be according to the network data set of each floor and floor relationship, where the visually interactive tools are being introduced to help to build the stair relationship. This module can load the indoor navigation models to generate 2D and 3D integrated navigation scenes. And this stair relationship also can specify the direction of stairs conveniently in the resulting scene. Okay, so this is how you can do the indoor navigation analysis. This one in 3D. So this is the navigation model. And so you can specify the start point and end point and run the path guide to view the navigation path intuitively, where it can help to verify the model's accuracy. So now we will take a 5 minutes break before we go to our live demo. I will pass the floor back to Anis.
All right, thank you, Shafika. Okay, so we will have a 5-minute breaks. So before that, I would like to invite all of you. Wait a minute. Okay, so I would like to invite all of you to attend our international workshop on GIS technology and application, which will be held from today until Friday. So it will be start from 4 p.m., which is right after this training. So I would like to welcome all of you to attend this workshop, and I hope to see you all there. And we will be right here after 5 minutes break. So see you on 5 p.m. Okay, so thank you so much, everyone. So see you in 5 minutes. Okay, welcome back everyone after your 5 minutes break. So right now we will move on to our second session, which is about the live demonstration in how to do the network and traffic analysis. So I will pass this floor to Shafika again. Okay, Shafika, all yours.
Okay, thank you, Agnes. So, wait. So, hi and welcome back, everyone. Now we will go to our last session for today, which is a live demonstration. So for today, we will create a network analysis by using a SuperMap desktop ads, where we will create two analysis, which is optimal path analysis and also TSP analysis, which is a traveling salesman's problem, TSP analysis. And if have sometimes, if have more time, we will also do some closest facility analysis. But for now, we focus on two, which is optimal path analysis and TSP analysis. So now I'm going to open my iDesktop ads. Okay, so this is my interface for iDesktop ads. So first, we will upload or import the data source into our iDesktop. And right now, as you can see, I already import my Dataset, which is my data source. And under my Dataset, I have the city boundary, hospital road, stop point as my data set. So this is the Dataset networks, which it is actually a network data set that I already create for a 2D network, but I will show you again on how to create this network. So I'm just going to drag it here. This is the network that has been created. Okay, so before we go, before we do this, I'm going to show you about the traffic analysis tab, where you can click this traffic analysis tab. And to create this Dataset networks, I'm going to delete this data set first. So you need to click this road and then go to this network by topology, which is default. So you can build a 2D network or 3D network and also customize the 3D network data set. But for today, we will do the 2D network. So we're just going to click it here. And then you can give the names or change the dataset names for the results, which I'm going to let it be like Dataset network. So for this split setting, I'm going to click this. We have two default, which is split line by point or split lines at intersection. So I'm going to click both of it and click OK. Okay, so now we have already built a 2D network using a road. So as you can see here, we have a two data set, which a Dataset network, which it is a line data set, and Dataset nodes, which it is a point data set. So you can browse the attribute table. And you can see here we have like two different nodes, which we have SMF node and SMT node, where SMF node is a distance probe node and SMT node is represent a true distance to node or a 2 point. Okay, so I'm going to close it and I'm going to add this data to a new node. Just click yes. Okay. So you can change the layer styles here. As you can see. Great. Then zoom in and change the layer styles here. And you can, so first I'm going to change the lines, which will be something. And then this one, I'm going to change the colors into red. Okay, but I'm also going to change the width into 0 to 1. Okay. So this is the build network that we already created, which it is in 2D. Okay, after that, we will go to our topic today, which we want to create the optimal path analysis, where we need to go to the traffic analysis first. And then actually this optimal path analysis, we will going to find the shortest time or lowest cost between 2 points in the network. Okay, so we will going to select the optimal path analysis here. And you can see there is two tabs that come out on your right, which it is the instance management and also environment setting. So in this environment setting, we can select the setting and change this network analysis, and we can also enable the traffic rule setting, which this one is disabled, so you can enable it if you want by clicking it. Okay, so for now, as we want to create an optimal path analysis, we will use the stop point here to create our optimal path analysis, which it is for the station. So you can just right click this station here, and then you can click import. Okay, so as I said previously, the data set that I want to use is the stop point. So I'm going to click the stop point, and then I'm going to click OK. So you can zoom up. And you can see that this is the stations that we already clicked. Okay, so this is the station 1. You can click here to check the stations 3, and it will come out like here, station 6, 8, 9, and so on. So as you can see, there's this station 10, although our previous station or stop point that we has only 9, because we also can add our station by using a mouse, which you can just click it. Here you can just right click and you can see this option, which is add by mouse. So this is what I just do, which is I just add a new station here, which is station 10. So after we do this, we can click OK, and have the analysis, run the analysis here. Just click yes. Okay. So this is what I told you previously, which is optimal path analysis, where it will show the path from the station 1 following the order station 1, station 2, station 1, station 2, station 3, station 4, station 5 here, and then go back to station 6, station 7, 8, 9, and 10. So this is what I told previously, where you can, where this optimal path analysis will follow the order, while for the TSP analysis are the one that won't follow the order. So this is the order that they follow, which is from the station 1, 2, 3, and until station 10. Okay, so now we are done with our optimal path analysis, and we will go to our traveling path analysis. Remove all of this. Okay, so as I told you previously, the main difference between TSP, which is a traveling salesman problem, also known as TSP path analysis, is TSP path analysis are not following any order, while for the optimal path analysis, it will follow order from station 1 until station 7. So now we will do the TSP path analysis, where we're going to select the TSP file. Under traffic analysis, we go to the network analysis. We will click this find TSP path here. Just click it here. And you can see here, it already changed. It has a stations, berry node, and also analyst node. So we can just click this station. Okay, it has a station 1 until station 9. So you can just run it, run this analysis. You can click here. And you can see that this analysis, which is TSP, didn't follow like the previous analysis, which is optimal path analysis, where it goes from station 1 to station 2 and then station 3, but it goes from station 1 to station 6, station 4, which it goes to the closest or nearest or lowest distance and lowest cost that it had. So you can see from 1, 6, 4, 5, 3, and until station 7, which it has the least route cost, least direction, and so on. So if you want to, like I showed you previously, you can add it by mouse. So you can also click which area that you want, like here, station 2, station 3, station 4 here. And then you can also run it to find the TSP path. And as you can see, instead of following the order from station 1 to 2, 3, 4, it follows the nearest, which is from station 1 to station 4, and lastly to the station 3. Okay, now we will do the okay, this is the traveling salesman problem analysis that we already done. So now, as we have some time left, I'm going to show you on how you can do the closest facility analysis. Where for the closest facility analysis, these analyses are being used to find out the least cost and the optimal path from the facility point to the event point, especially when you have like accident and you want to find the nearby hospital and so on. You can use this find closest facility. So you click this find closest facilities tab here under network analysis. So for this closest facility, we're going to import the hospital into the service stop and right click, which is going to import. As you can see, the dataset is hospital, and you can the field can be from the OSM too, but for the name field for this service stop that I want to do is I'm going to click this name and click OK here. Okay, so this is all of the hospitals that we have in Dhaka City, and in Dhaka City we have 111 hospitals. So I'm going to focus on here only. Okay. So when you want to add the event stop, like maybe, okay, you just click this event stop and you can add any event stop that you want. I'm sorry, there is a construction nearby. Okay, so you can add any event stop at any area that you want to check which facility is closest to your event stop. So you can imagine this event stop that I created or I click is like maybe the building that have a fire, under fire. So we need to transfer the peoples in this building here. I want to the building here to the nearest hospital. So you can click here. And then you can go to this parameter setting. So you can, in this search setting under search direction, it has event facility or facility event, where either you want from your event, which is like I'm having a building the under fire to the hospital, or you want from the hospital to like the ambulance to take the patient from the building. If from the hospital to the building, you need to click this facility to event. But right now we want from the areas to the hospital, so we can click this event to facility. And you can check the facility number that you want, like how many nearby hospital that you want to transfer the patient. So I'm going to click maybe 5 hospital here and click OK. And then you're going to run it. So after you run it, so as you can, where's the result? Okay, so this is the 5 hospital, which it is nearby your event area or your buildings that have an accident. So these 5 hospitals, as you can click here, is the Mater Care Hospital, ENT Hospital, General Hospital, and other type of hospital. It will give you directly which hospital is the nearby your incident places that occur. Okay. So before I forgot, this is how we can find the closest facility analysis by using SuperMap at desktop, where you can add the stop to maybe any places that you want. So you can remove, or if you want it to be in some other areas, like in these areas, you can just click event stop and mouse and just click here to find, and click this parameter again to find which facility numbers that nearby your area that you want. So you can just click 5 and click OK, and then you can run it again and you can find out which hospital is your nearby hospital towards the incidence or your area. So this is how you can do the optimal path analysis, TSP analysis, and find closest facilities analysis. So under network analysis, not only we have that tree analysis, we also have the service area analysis. We can also find the MTSP path, and we can also do allocation analysis and allocation analysis, where we can also do the transfer analysis. And under dynamic segmentation, we can generate a route, calibrate it, and generate a spatial data, and so on. So I think that's all from me today. Thank you. Back to you, Anis.
Okay, thank you, Shafika, for such an amazing demonstration about the traffic analysis. So for your information, the other analysis will be uploaded as a short video on our SuperMap YouTube channel soon. Okay, so right now we are open for Q&A. So if you have any question, you can just type in the Q&A chat box, or maybe in the chat box. Okay, so I think there is no further question from all of you. Okay, so I would like to welcome all of you to submit your result to check whether your work correct or not, so we can help you to check it. So for this week, you can upload it in the folder of week 7 for the traffic analysis. Okay, so I hope to see all of you next week, our last training, which is about web platform. So this one we will introduce about our iServer, iPortal, and how to publish your map online. So this is basic information on our web platform, SuperMap. Okay, so thank you so much, everyone. And I hope to see you all after this for our workshop, and also next week for our web platform GIS. Okay, thank you so much. Bye-bye.